In this tutorial, I will be discussing the numerical problems on heating effect of electric current. But before that, let me first revisit the formula which we have learned so far with respect to heating effect of electric current. Because we studied two formulas, and these are the two formulas that we will be using for the numerical problems. So these formulas are related to heating effect of electric current. So the first formula that we have learned, and this formula is the one which you will be using very frequently, that is H equal to I to the power 2 into R into T, where I equal to current flow in ampere, R equal to resistance in ohms, and T equal to time in seconds. There is another formula which we need to use when we will not have the value of I or resistance. But if we know the power of the electric equipment, like for example electric heater, then we can use another formula to calculate the heat produced, and that formula is H equal to P into T, where P equal to power in watts and T equal to time in seconds. Now let me read out the numerical problems, but what I will do is here, these are the things I will do. First, I will read out the numerical problems. 2, I will solve the first problem just to show you how to use the formulas, and then I will expect you to solve these problems on your own. That means out of these 3 numerical problems, I will expect you to solve the remaining last 2 numerical problems, and I will be discussing the solutions of those problems in the next tutorial. So let me repeat what I just said. I will read out the numerical problems, solve the first one, then I would expect you to solve the remaining 2 problems, and in the next tutorial I will show you how to solve the last 2 problems, and by that time you should be in a position to verify your results with mine. Okay, therefore let me start by reading out the numerical problems. So keep your pen and paper ready, and at any point in time you can pause the video and you can write down the numerical problems on your paper. First one, a potential difference of 250 volts is supplied across a resistance of 500 ohms in an electric iron. Calculate 1. current flow, and 2. heat energy produced in joules in 10 seconds. Now I will read the numerical problem number 2. Calculate the heat produced when 96,000 coulombs of charge is transferred in 1 hour through a potential difference of 50 volts. Now I will read the problem number 3. 2 conducting wires of the same material and of equal length and diameter are 1. connected in series, and then 2. connected in parallel in a circuit across the same potential difference. find out the ratio of heat produced in series and in parallel connection. And now I will show you how to solve the numerical problem number 1. Now here we know the potential difference, that is V, which is equal to 250 volts. We also know the resistance, which is equal to 500 ohms. So first thing that we need to find out is the current flow. So therefore current flow I equal to potential difference upon resistance, that is from the Ohm's law, V equal to I into R, or I equal to V upon R. V is 250, R equal to 500, so this is coming as 0.5 ampere, which is the current flow. Now the second part of the problem, heat energy produced in joules in 10 seconds. So here we will be using the formula H equal to I to the power 2 into R into T. Now we have already calculated the value of I, which is 0.5, so it is coming as 0.5 square into 500 ohms into 10 seconds. Now 0.5 is 1 by 2, therefore it is 1 by 2 into 1 by 2 into 500 into 10, which is coming as 5000. So that means 5000 upon 4, which should come as, I think it should come as 1250. Yeah, it should come as 1250 joules. Joules. In fact, we can show it in the calculator also. (5000) upon 4 equal to 1250 joules. So now we solved the second part of this problem. So so amount of heat produced is 1250 joules. So what I will do from the next tutorial, I will discuss the solution to the remaining two problems. So I would request you to solve these remaining two problems on your own and then verify your results. I'll see you in the next tutorial.